Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 9.3, second order ordinary differential equations. So for second order differential equations, there are two main things that we work with. The first one is the auxiliary equation, and the second one is the trial function. There are two main types of ordinary differential equations. One of them is homologous, which means that there is no trial function, or you have an expression of differentials equals to 0. For example, you have y dot plus y, y double dot plus y plus y double dot plus y dot plus y equals to 0. That is one homologous differential equation. Homogeneous, sorry. This will be a homogeneous equation, but there are also cases when you have x double dot plus x dot plus x equals to cosine of t. That would not be homogeneous. Sorry, I keep saying the wrong thing. This will not be homogeneous, and it would have to be further worked. So on the left, we will this part we can solve to get a general solution, and this, on the right, we will need to solve for the general solution, then add a particular integral on the at the back, which I'll talk to you about how you can try to do that. So let us give this a shot. First of all, we need to look at this whole expression in the general form. So the general form is all the differentials on the left, and you have the variable on the right. So let's first do the auxiliary equation, which goes as lambda squared. So second order goes to squared. This would be a negative lambda, and this would be minus 2. So if you look at it, each differential or each dot or each dash, whichever case, you will get a power. So for a double dot, we have a 2 squared. We have a squared function. For a single dot, we have just lambda, and for no dots, we have just the coefficient. So with that, we can call this equal to 0 for a homogeneous equation, and that can be solved by quadratic formula or factorization. And this whole equation, which equals to 0, is called the auxiliary equation. We can factorize this, so x take 2, lambda plus 1 equals to 0, and solve for lambda. Lambda equals to 2 and minus 1. So with that, we can now, with this information, we can work with it, and you can say just you can trust me on my word that this would mean that you have a general solution y equals to e to the lambda t, because this is dot and it's by dt. So it's the lambda times the variable. Sometimes it's x if it's dy by dx. So d2y by dx squared take dy by dx take to y equals to e to the 3x, then you use x in place of t. So from this we can say that because we have two different lambdas, we have two terms. So we have e to the 2t plus e to the minus t. Make sure you have a coefficient for each, so a and b. So we have a general solution of y equals to a e to the 2t plus b e to the minus t. This would be our general solution. Note that there is no plus c just yet, because we don't need to add this until we solve the second part, which is the particular integral. So particular integral, we need to use the trial function method, which, looking at the value on the right, you can kind of estimate or guess with enough practice, that is, that the trial function that I want to use is a c e to the 3t. And you can add a d, but that wouldn't make any difference because d would be 0. And so you can now differentiate such that we can get a lot of different terms. And we have 9c e to the 3t over here. So now we have y dot and y double dot, and we can use that to our advantage and calculate c. So with this, we substitute in the dots. We can get an expression of 9c, take 3c, take 2c equals to 1. And note that I cancelled out the e to 3t. And with that, we can calculate, so minus 5, so 4c equals to 1, and c equals to 1/4. Okay, so we have this particular integral. Now we can add on the particular integral, which is 1/4 of e to the 3t. And make sure you have plus c afterwards. And yes, that's all for the second order differential equations. Now we can apply boundary conditions to solve for a and b and c. So normally if you plug in, let's see, if you plug in the first initial position versus time, or y and t, so t is 0 and y is probably 0 as well, then you can get a polynomial a and b. Then you, after that, you can substitute in the value for actually no, this c is unnecessary, isn't it? I've got so much in my mind I can't quite remember. Yeah, this is not a thing, so we have the particular integral. That's fine. And we can differentiate this whole expression to get another boundary condition, which is a y dot at time t equals to something, and you can plug that in, and you will end up with two equations of A and B, which you can do simultaneous equation on to solve. Yeah, basically that's it for second order. So yes, indeed the plus c is included in the particular integral, and so I do not actually need to add the c. And one thing I need to state is that this second order that I've done the example on is a very special case that doesn't normally happen that much, and so you will need to learn quite a few more solutions, starting from having complex solution for auxiliary equations. Then you'll get some trial functions that would conflict your auxiliary solution, and of course there are also double roots for auxiliary equations that you need to take care of, and I'm going to tackle them one video at a time, and hopefully you can I can break that down a bit better over a longer period of time, because if I jam everything onto one equation, this video would be about at least 40 minutes long, and it's not gonna be fun to watch at all. So here we go with two questions. This time I've created these questions by myself, and they should work, because second order is a bit easier to formulate than integrating factor questions. So yeah, basically go for it and do a lot of practice and get good. So yeah, I'll show you the answer in 5, 4, 3, 2, 1. And the answer is shown right here. So these are relatively straightforward. There aren't much special to them. Bear in mind that we have in this question 2, we have a plus or minus as our square root of 4. So we have the lambda as plus or minus 2. Other than this, there aren't much else to talk about in this video. I hope you've learned something. We are gonna cover a few more different cases for next video and the video following that. But for now, thank you for watching, and I will see you on my next one.